start our video today, I just would like to mention all the good content that we already have in our channel and encourage you to check all that out. And I would appreciate if you subscribe to the channel and hit the like button so you don't miss any future videos. Today we're gonna be covering basic fundamental data types that we typically use in our program. So it's very important to understand those ones, and this will be more like a recap or refresher for the previous video I have done regarding tags and data types and so forth, which is available in the channel. Okay, so the first one I'm going to touch on is in the data type is the bool. So when we declare a tag as a bool, so that tag or that variable can only be either 0 or 1. So something like maybe a switch, it's either on or off. Something like, for example, a level switch, that could be, if it's, let's say, a high level switch that allows to monitor some level on some tanks or something, it's either going to be high or not. So it's going to be, again, either 0 or 1. If I go here to monitor the tags where I can see the value, it's either 0 or 1. If I try to put something else, it won't take it. I'll say it's invalid. Well, that makes sense because this is just a bool, just a bit. It's 1 bit. So it's 0 or 1. It's just simple as that. Okay, so next one we can touch on is what we call a byte. Now in the Rockwell PLC here, what they refer to that, like the byte, which is more of a common term when we're dealing with the bits. They call it cint or simple integer. So a cint or a byte, it's simply bits, and we can see here that as we expand this from the plus sign here, that we have 8 bits, and with 8 bits we can have a value of up to 127 is your max that you can have, or on the negative side it will be negative 128. So the byte here, or this tag, the value cannot go below negative 128 and cannot go above 127. So if I try to go below 128, like 129, it won't take it. It says I can't take that. And then in the same way, if I try to go above 127, it won't take it. It will only take 127. And obviously, where's that coming from is because we have 8 bits, and that's for the cint and how it works for the type. Now, or the byte, which is more a common term. Now let's go to the other type that we can use, another basic type, which is an integer or an int, or a word. That's another common term that you will probably hear, a word. And a word is simply 2 bytes or 16 bits. So now if I expand this, you will see I have now, instead of 8, 0 to 7, I have 0 to 15. So that's my 16 bits. That's basically combined together will give us one integer or one word. Now again, the maximum we can put in here for an integer will be 32,767. So if I try to put 68, it won't take it, as you can see here. because that's the maximum you can, that 16 bits can do. And then on the negative side, it'll be negative 32,768. If you try to go below that, you won't take it. Now a quick way, you know, if you don't remember, okay, well, like what was the minimum I can have for, you know, an int or a cent or something like that, a quick way to tell or know, you can simply just, you know, so let's say I have here, just gonna put 0. You can just simply go to your tag and go to the last bit here, which is 15, and just put a 1 in there, and then you get the, you know, the minimum right there. And then in the same way, if you want to know what's the maximum value you can put here, if I put here 0, then simply just put 1 in all these 15 bits except the last one. So just leave it at 0, and then you get your value in there, 32,767. That's how you get your range. So that's another basic or fundamental type that's very important to understand how it works. The other basic one is what they call here double integer. So double integer or double words, it's essentially 4 bytes. So if I open it now, I have like 0 to 31. So that's 32 bits. And again, with the same trick we learned earlier, if we want to know what's the min and max we can do here, I can just simply put 1 in the last bit, and it's going to tell me it's like, you know, 2,147,483,648 negative. That's your on the negative side. If you try to go below that, it won't take it. There we go. It will say it's, you know, underflow. And then in the same way, if I want to know on the positive side what's my max, then again we can do the same trick. And I can just put 1s. Here we go. And now we get your positive max you can put. If you try something higher, it won't take it. So that's the double integer in here. So now that we saw how the int data type works, we also in later firmwares, I believe firmware 24 and above, Rockwell introduced a new fundamental data type. They call it long integer, and essentially it's instead of 32 bits, it's a 64. So in scenarios where you need a number that's, you know, above 2 billion and so forth, however, the max for the int, then you can use the long int. So and that will allow you to go like really big number. It's 999 quadrillion and 999 trillion, 999 billion and million. Anyway, it's a big number that it's 64 based on 64 bit. And if we want to see that in the style here, I can go and say I want the representation or the style as binary. And if I do that and go to monitor, I can see here is all the bits, and as you can see, it's 64 bits. So just keep that in mind. If you do need a number for some reason, you know, like higher than what the double integer can handle, you can certainly use the long integer, which is 64 bit, if you'd like to. So another data type we're going to look at here is real. So real is basically when we need a floating value or a real value, you know, number with decimals and all that. Then we can use the real data type to represent those numbers. So if I go here, you know, I want you know, something like 10.6 or something like that. Then we can use the real for those type of tags or data types. And the real can take a really big number, something in the power of 32 or something like that. Believe if I do something like this or like this, plus 0.38. Okay, that doesn't take that. 30, maybe 7. There we go. So it could be a really big number. I don't know. I don't even know how do you say a number this big. But anyway, and also on the negative side, you can also go with really very small number as well. So the resolution on the real is quite large. So now that we covered the basic data types, we're gonna address another aspect of, you know, tags and data type and so forth, and that is of creating arrays. So let's say, for instance, you know, this tag 1, it's a real, and it represents maybe a level in a tank, or maybe a speed, or something that's it's an analog of nature value. But now you have like a few of these. So rather than doing something like this, tag 2, and I'm gonna make this also a real, and tag 3, and then I'll do this as a real, and tag 4. So you got the idea. So rather than creating this, so let's say I have 4 of these, or maybe 10 or 20 or whatever. The other way that you can do this, you can come here and you can say, well, these are my maybe values. You can call them values, and I'm gonna see these are of type real. And then if you click on this little button here, it brings this this pop-up, and then you can see here all the data types that are available. One thing I would recommend here, I check this box, and the reason I like to do that, so that way you can see like all of these data types, they belong to the predefined. So that's means that's out of the box data types. This is what the software Studio5000 gave you as data types. And then if the user created some custom data type, which we're going to see here in a moment, then you can see that as well in a different folder that's going to say user defined rather than predefined. Then you can differentiate which one is custom defined and which one is out of the box data type. Anyhow, so now in here I can say, well, I have like 4 of these, and I say okay, and you will notice here that we have 4 between brackets, and then if I expand this now, it's going to say, okay, we have values, first element 0, 1, 2, 3, and each one of these can represent your values that are your tags that you are representing using this. So rather than creating 4 tags, you can have one tag, which is an array. So an array, it's essentially like a table. Okay, so in this case here, it's like just one dimension table. So it only has basically a stack. So something like essentially just gonna, so in this case here we have something like essentially like this. I can draw, and here's your 0, 1, 2, 3, and this is basically your array, which is called values. And then here's your element 0, element 1, element 2, element 3, and each one of these can hold a real value that you want to represent. So the benefit of this is essentially, you know, now you're encapsulating your data into less, less tags essentially than doing it this way. But in some cases you might want to use it this way. Now one thing here that I would like to actually mention, since we're talking about these arrays and this versus this. Now notice here that one of the benefits of this is you can customize the name of these tags or of these variables to whatever you want. Where when you create it as an array like this, it limits you to, you know, that the name of the first one is going to be value or values 0 between brackets, values 1, values 2, values 3, which, you know, could be a little bit harder to know. Okay, what does values 0 represent? Is it that level on tank 1, or is it the level on tank 2, and so forth? Where when you present it this way, you can say, you know, this is tank 1 level, you know, something like this, you know. So it's very descriptive just right from the name. So a way around that is you can put some description on your I mean, you always need to put description regardless on your tag. So you can put, certainly you can put descriptions in there. The other way around this is using aliasing. So when you use aliasing, and that's, you know, another attribute for our tags, so that's will be a good example to demonstrate how this alias works. So what I can do now, I can use the same name in here, or whatever name I want. So I can say, well, you know what, tank 1 level. Okay, so tank 1 level will be represented with an alias, or is going to be pointed to an alias, and the alias is going to be this values, and it's going to be this one here. So now what we did is basically we gave this a label, which is called tank 1 level, which is more descriptive. And now in my program, if I go to my program, and let's say I used you know, something like a move or whatever, I can now use just tank 1 level, and it would know that that is value 0. So rather than just use value 0, then you can use tank 1 level, and that's how, you know, you can take the benefit of using arrays and also having a unique name of your array elements, and be more descriptive and more straightforward in your programming when you're referring to your data and all that stuff. So that's how you can take the benefit of both the aliasing and the arrays. Now another level of the arrays is sometimes you might need more than one level. So you might want another dimension. So let's say maybe I can have 2 dimensions array. If I do here 4, for instance, then you will see you'll have 4 and then 4. So now we can refer to 16 elements using this array. And the way this works is if I go, so now it's obviously complaining about this because the address is not right, so I'm just gonna fix it here. There we go. And the way this works is it's like this. So you'll have 0, 0 is your first your first element, and then 0, 1, and 0, 2, and so forth, and then you have 1 and 2 and 3. So essentially it's like a two-dimension table, something like essentially with 4 rows and 4 columns, so something like that. And then I'll have 1, 2, 3, and 4, and then same here. So this will be 0, 1, 2, 3, 0, 1, 2, 3. So the first element, which is here, so that's 0, 0, and then we have also 0, 1, and then 0, 2, 0, 3, and then 1, 0, 1, 1, 1, 2, 1, 3. So sometimes you might want you know, a 3-dimension basically array. So the way to do that, again, we can simply just go back in here and then maybe add another element. So now we have 3-dimension. So this becomes like a matrix essentially, and again it's going to require, you know, the x, y, and z if we're talking about axes. And now it's going to be actually 64 element that you can have in this matrix that you can refer to. So again, you'll have the first element 0, 0, 0, and then 0, 0, 1, 0, 0, 2, and so forth. So that's how the array, you know, in this instance works with dimensions. Now this is good. However, sometimes you might want to combine, you know, different data types together. You know, let's say for instance you have you know, a bunch of transmitters, analog transmitters, and you know, for transmitters you're gonna have the signal. Obviously you might have scaling for that transmitter, you might have some alarming, some bypasses, some statuses, and so forth. So it might make sense to have a, you know, a custom data type that will have all these things together. So in that case, what you want to do is you want to basically create your own data type. So a way to create your custom data type is you'll have to come here to this folder here called user defined, and then you create new data type. You right click on it, you can create your new data type, and then you can name it. So this name, you're going to name it, that's what's going to become available as a data type. So I'm going to call it analog, or I'm going to call it simply transmitter. Okay, and you can give it a description. Say this is custom data type for transmitters, for example. Okay, and then in here we're going to say, okay, well, what do I want in this? So we can say, well, we can have the value that's going to represent our analog signal, for example. And since it's an analog, this is going to be a real, for instance. And then we can say this is transmitter analog value, for instance. We might want to have, for instance, a fault status. Okay, so that's going to be for instance, a bool. And we can say this is transmitter fault status. We can also have maybe a scaled value. That will be a real. So this will be the transmitter scaled value, for instance. and so forth. So so we can have, you know, we can have like as many members as we want. We might also want like maybe a tag for our transmitter, and this could be a string, for instance. And then we can call this transmitter tag. Okay. So once we once we add all our members, then we just say apply. And now we have this, I can spell this properly, transmitter. Okay, I can hit apply and I click OK. So now I can go here and I can say, okay, I'm going to have my transmitter 1. And the type now, you will see when I type transmitter, it's become available. And even when you go here, you see now it's in this user defined, like we talked about earlier, because we checked this box. So now it shows me, oh, you have a transmitter that's user defined. Okay, that's cool. So now once we define this transmitter, now we can see, okay, it has a value and a fault and all this stuff that we declare earlier or define. Well, that's good. So now I can have one tag and this one data type, and it has all the stuff I need for my program to link to. So I link it to value, to a tag, scaled value, and so forth. Now the other thing to keep in mind is, like, well, let's say I have a bunch of these transmitters, not just one. So again, rather than maybe do transmits trans 1, trans 2, trans 3 like in here, we can actually have an array of a custom data type. So we can just simply, if I want, let's say 10 of these, I can just do between brackets 10. That's another way of doing it. And that will give me 0 to 9 transmitters, all good to go, with all the data that I declare earlier in that data type. And the beauty of this also is, if let's say for some reason I need to add a member to this custom data type, you know, I found out, oh, I might need, you know, some alarming to this transmitter. Well, you can now just go here and say, you know, I'm going to have alarms, for instance, and I can say this is going to be maybe a dint. Okay, and now, you know, this will represent the alarm. So I can say maybe if it's 0, it's equal to okay. If it's maybe 1, we have a high. If we have 2, we have a low alarm, or something like that. It doesn't matter. The idea is here is when I apply, I say yes, now this new member will be available in all of these. Here it is. Just by changing it just in one place, it's changing all of these in one shot. The only thing to keep in mind is this change or this modification we just did, I was able to do it because I am offline with the PLC. If I was online, then unfortunately you won't be able to modify this UDT online. So just keep that in mind.